So in the first session means the session just before this session, Sabina talked about why a multidimensional analysis is required, just going beyond any particular dimension, especially income. And we will follow, and that is the motivation. And the rest of the summer school, we are going to talk about multidimensional poverty analysis, its properties, how to use that tool, methodologies, theoretical methodologies. But before that, why don't we review the single dimensional aspect? Because most of these techniques in multidimensional analysis has been borrowed from the single dimensional counterpart. And of course, there are certain things that you cannot do in the single dimensional context, which has been extended in the multidimensional context. So, what I will, lecture in this session will come back again and again this week and also in the next week in different contexts. So in this session, I'm going to just give you a brief review. Properties that I will discuss again properties in the multidimensional context in the next session after this session. Tomorrow morning we will talk about the multidimensional methods, and you will see these concepts coming back again and again and again. When we are talking about sensitivity and robustness analysis in the multidimensional context, again we will be using the tools that I will be talking in this session. So this is a review of the unidimensional poverty measurement. The sources, mainly we shared with you chapter 2 of the book on multidimensional poverty measurement and analysis, written by OPHI colleagues. You will see chapter 2.1 has a very brief review of unidimensional measurement. And there is a book that I wrote with James Foster with two World Bank colleagues, which the title is A Unified Approach to Measuring Poverty and Inequality, Theory and Practice. It can be downloaded freely from the World Bank website. Then of course, the Bible in this literature is the book titled On Economic Inequality, written by Amartya Sen, and then the annex has been added by James Foster in 1997. And then James Foster wrote a piece on different poverty indices, so that's also worth reading. And then you will have other articles that you may read on top of these readings. They are available in the booklet that you have been provided. So, as Sabina suggested, or actually mentioned in the morning session, that this and the next session is going to be a bit challenging in terms of technicalities compared to the rest of the summer school. So we hope that you'll be able to grasp the session. Stop me, pause me if you have questions, if you do not understand anything. Happy to explain more than once. But the rest of the concepts in the summer school will build up on these concepts. So we start with preliminaries. When we are measuring poverty, we talk about a reference population. It could be either a country or a region or a particular population subgroup such as ethnicity, and we refer with this reference population, we call it a society. So whenever we say a society, it could be a country, it could be a region, it could be a particular social group. Then of course we need to decide on the unit of measurement. What is our unit of measurement? Is it the unit of measurement is persons? We have information at the personal level. We have information at the households level. If we are interested, say, in child poverty, the unit of analysis is children. If we are interested in measuring women autonomy, unit of analysis is women. okay, and so on. So here, for simplicity, we will just assume that we have information for each person in the society. So suppose this society is there, and this society has n number of people. It could be 1 million, it could be 100, whatever it is, which is denoted by number n. And n may vary because we need to compare societies with different population sizes, right? India is a big country, and then compare with Nepal, which is much smaller. But we should be able to compare them. So n can vary, even over time. Today, we have one population. With population growth, we have a different number of people in the country. So n, we allow n to vary. Then there you will find a list of variables or dimensions, however you call it, used for assessing poverty. And we refer that set of variables as space for measuring poverty. In the world of income poverty measurement, it's either income sources, income from various sources that you get and add up to get total income, or it could be a set of commodities, available in a commodity basket. And in general, when you are making strict comparisons, it is assumed that there is a fixed set of variables, because when we change the commodity basket, poverty comparisons may become difficult. You may not be able to compare. So if you have two different sets of commodity baskets and prices, one may argue that these, and you create poverty indices, they may not be comparable across time. But if you have same set of commodity baskets, life becomes much easier. So we just assume that there is a fixed set of commodity baskets when you are comparing across countries and so on. But for practical reasons, in income poverty or consumption expenditure poverty analysis, people choose different commodity baskets. Okay. By achievement, we mean the performance of a person in a particular dimension. Okay, so if you have the income sources, wages, you may say that what is the wage of this person I? So wage is a particular variable here. You have kind of wage, you can have rent, whatever different source of income, or different commodities. Okay, so Xij would denote a person's achievement in for person I in dimension j. So it could be the consumption of rice by a particular individual. And all these achievements of n persons, so our society has n persons, and poverty is measured by d different variables. And we assume then these achievements of all n people in d variables, they are summarized by a matrix that is we call X, capital X. So this matrix has, you have n times d elements. So for each person, persons are referred in rows and dimensions in columns. This is typically what you see when you use a data set, right? You have a set of people, and then you have for each person you have the information. This is how it looks like, and we just denote it by a matrix. Now, achievement vector of a person is this one. So if you look at that, if we say that look at the achievement vector of person 1, this is given by this particular row. Okay, achievement vector of person 2 and achievement vector of similarly person n and so on. Now the achievement vector, what does it contain? An achievement vector may contain say d different income sources of that person, or d different commodities consumed. It's a commodity basket. Okay, so this is an achievement matrix summarizes. Now, in the income approach or consumption expenditure approach, what we do, we compute an overall achievement somehow from the achievement matrix. We denote it by, for person I, we denote it by xi. So, xi is obtained by meaningfully combining d dimensions or variables, d different income sources, d different commodities. We meaningfully combined to obtain an overall achievement of the person, which we refer as xi. It is also referred at different places by resource variable, welfare indicator of that particular person, and so on. Now, when the space is set of income sources, you have different, for each person you have say 5 different income sources. You compute the total income of the person by just summing up all these income sources. So, Xi is just a summation of incomes from different sources, which is denoted by this particular term. Okay, so income, total income, overall achievement, the total income of person I is the summation of incomes from different sources, D different sources. When the space is a set of commodity consumed, then it is assumed that there is a market price, a set of market price for each of these commodities, and in this case the total consumption expenditure of a particular person is computed by taking price times the commodity, and this gives you the total expenditure. So this is the consumption expenditure approach simply, and the other is the income approach, and these both approaches are used in income poverty analysis. The overall achievement vector, so we have the achievement for each of the n persons, 1, 2, 3, 4 up to n, and these, the achievements of the total achievement of these n people, they are summarized just by this vector called small x. So capital X denotes the entire matrix where you have the information of each person in different dimensions or variables, and the small x here is just a vector of n overall achievements. Let us take an example. Suppose there are 4 persons in a society with overall incomes of just these 4 numbers. Okay, you can use any other currencies as you want. Then simply x is equal to 9, 4, 15 and 8 is the vector representing the incomes of the society. So income can be presented, I will present another way that generally we see the distribution of income, but this is also an income distribution. So if one asks what is the income distribution of a particular society, well, if you present them in terms of vector, that becomes the income distribution. In general, when we say draw a frequency distribution or a cumulative distribution that I will present next, we need to order those incomes. It's something called Payne's parade. That means you rank those individuals based on their incomes, and then that gives you sort of a distribution of income. So it is quite necessary in that sense to order the distribution. So if you order this distribution 9, 4, 15 and 8, it becomes 4, 8, 9 and 15. Now the cumulative distribution function that is often used in understanding income distribution. So if we have this vector x equal to this, it can be represented by a CDF. The CDF of distribution x we denote by fx. How does it look like? Now if we want to denote the distribution, what it says, how many people, so if you look at say B denote a particular level of income, if B is less than 4, how many people have B less than or income less than 4? None, so 0. How many people have say less than 4 less than equal to B less than equal to 8, that means B between 4 and 8, 1/4, okay. So this is how it goes, and when you plot a distribution, this is how it generally looks like. So if you ask how many people have income less than these, how many people have income less than these, and so on. Typically, for a society with large population size, this is how a distribution is presented. So, what does a CDF tell us? What is the intuition behind the cumulative distribution function? It tells us the share of the population having income less than a particular level of income, which means if you have fx4, which is given here, is the share of the population having income less than $4. Okay. Similarly, Which fraction of population has income less than 8? This is the fraction. And when it touches the upper bound, which is equal to 1, it means that this particular income level, you have everybody in this society less than this income level. That means that is the highest level of income. So this is what a cumulative distribution summarizes. And we will come back to it again tomorrow morning, and again when we are doing the robustness test and so on. And you will see how this distribution, this kind of cumulative distribution function is used in poverty analysis, single dimension context. Now, this is something that Sabina was also talking about in the last session, that a policymaker is generally interested in 3 different aspects of a distribution or a vector. Size is just following the terminology of James Foster. I'm his student, so I tend to use his ideas. So size, which is generally about welfare, human development index, per capita gross domestic product, happiness index, they generally measure the size of the entire distribution. So you have the distribution and you want to know, okay, let me give you a number, particular number from this to this distribution, and that's actually the welfare analysis. Spread, how is the distribution? Is it spread too much or not? If it is spread too much, that means it has a higher level of inequality. Okay? And then finally the base of the distribution. That means you focus on the lower end of the distribution. So you have this distribution. So for poverty analysis, you just focus on this particular part of the distribution. You are not interested in the entire distribution, because the entire distribution gives you the idea of welfare. Okay? So it's just the focus remains in that part. That is called the base of the distribution. Now in this summer school, especially we are interested in the analysis of poverty. So we are interested in this third aspect. We are not going to talk a lot about the overall welfare or overall inequality. Rather, our focus will remain on the base of the distribution, that is poverty. Okay? Great. So now we come to the discussion of poverty measurement. We measure poverty, given that we have the achievements, or we have selected the variables, we have the information of all individuals. Now next what? Now unidimensional poverty measurement involves 2 steps. The first step is called identification, where we are going to identify who is poor and who is not. And the second step involves aggregation, how we summarize all this information that gives us the idea of the level of poverty of the society. So identification basically asks who is poor. So you should be able to say this is poor and this is not, because when you have this distribution and you are focusing on the base of the distribution, you should be able to say what is the borderline, who is these people at the base, who are not at the base. So that's called identification of who is poor. And this step dichotomizes thus the population into a group of poor and a group of non-poor persons. The main tool that is used here, and you all have heard and used so many times, poverty line, a very controversial decision. Person I is identified as poor if the overall achievement, the total achievement, which is total income or total consumption expenditure, lies below that particular poverty line, and non-poor if it lies above the poverty line, equal or above the poverty line. That's the idea. That's how poverty line is used. What is the significance of poverty line? It enables policymaker to identify a group of people who are subject to different social assistance. That's the targeting part. So when you want to target, you need to set a poverty line, because you cannot target the entire population. That is not your motivation. And poverty line can also work as a benchmark, where the objective of the policymaker is just to bring those under the poverty line to that particular threshold. So if you say that, say, nutritional calorie intake is used to create absolute poverty line. So if you decide that 2100 kilocalorie is the minimum requirement. So you have to give minimum this amount of expenditure so as to bring the people or let the people consume at least 2100 kilocalorie. If that is the threshold, a government's target would be to those who has below that particular poverty line to bring them at least to the poverty line, because that's a threshold you set. Okay, that's the significance of poverty line to use as a benchmark. Okay. Now, I introduce something called censoring at poverty line. We will be using the term censor matrix, censor achievements quite a lot of time. Let's see, what is censoring? Now, having Z as benchmark, it will allow you to create the censored distribution. What is a censored distribution? A censored distribution, what you get from the original distribution, is you retain the total achievement, total income, total consumption expenditure of those who are below the poverty line. So you retain the achievement, the performance of those who are poor. But at the same time, as I said, in poverty analysis, you are focusing on the base. You don't care about the rest. So what you can do, you can replace the rest by the poverty line income. That means they have already achieved that target of minimum poverty line, the minimum amount of income or consumption expenditure necessary to have a good life. So this is the idea. So here you retain the total achievement or income of those who are below the poverty line and replaced by Z for those who is either at or above the poverty line. So this is called censoring. So you have a distribution which goes like this, but then it should stop. Okay? An example. Let us take an example to understand it better. Suppose we have this vector which we considered earlier, that means 9, 4, 15 and 8, and suppose the poverty line is 10. So how many people are poor here? 3. So this person and this person. So we retain the incomes of these 3 persons. However, we replace the income of this person by the poverty line. So X star will retain the income that are below poverty line, but will replace the income that is above poverty line by the poverty line itself. That is called the censoring. That is the censored distribution, and we will visit it several times during the course of our sessions in the summer school, in different sessions. Now comes the part aggregation. So we have identified. So given that we have set a poverty line, which I'm not going to the different concepts of poverty line. There's absolute poverty line, relative poverty line, but the main idea is that you dichotomize the population into 2 different groups. Now, after you have divided them into a set of poor and set of non-poor, how do you aggregate? Because you should be able to say that poverty has gone up, gone down, remain unchanged. How do you do that? That's the part called aggregation. So the main question that one needs to answer is how poor is the society? So this step constructs an index of poverty summarizing this information for each distribution and for poverty line. So given an X and given a Z, selected poverty line, P of XZ, or we can write it in terms of censored achievements vector, because X and Z both are used to construct this. This measures the level of poverty in the distribution. So we don't know which poverty measure we will be using. There could be different poverty measures. So the idea is that we just do not use whatever we want. We just need to use a measure that satisfies certain desirable properties. Okay? But anyway, this P is a general measure. It could be anything. You can come up even with a particular measure. Okay? But it needs to satisfy certain principles. This is what we are going to discuss next. That how do we select a particular measure that will serve our purpose? You could simply count the number of poor. If that is a good measure, that is what $1.25 a day does. That is what the national headcount ratios do. Let's see. Let's discuss some of the properties that are ethical, and from a philosophical point of view that are required. However, some of these properties can be controversial because these properties depend on certain norms that one may follow. So, two important things are there. It is important to know while devising a poverty measure which properties the measure should satisfy, and it is crucial to understand how a poverty measure should behave to different data transformations. That's the main idea. Let's see what there. Suppose you are asked this particular question: should the poverty measure increase if the achievement of a poor person rises while that of others remain unchanged? So suppose you have 10 poor persons in a society, and for 9 poor persons there is no change in achievements. For one person the achievement increases, income increases, the poor. Do you think poverty should increase or decrease? Overall poverty? Decrease? Okay, and probably that's where we would agree that a poor person's condition has improved, it will decrease the overall poverty. Should poverty comparisons change when achievements are expressed in different units of measurement? We are measuring in terms of dollar, we change it to pound, or we change it to, say, Indian rupees, Chinese yen. Should the poverty figures change? Probably no. Then you may ask, should a poverty measure increase as the number of poor increases irrespective of any change in the population size? You have a certain growth in population, you have either increase or decrease in the number of poor. Should somehow the figure, overall poverty figure, be affected by the change in the population size, or it does not matter? If the total number of poor goes down, that is what we care. It's also a decision, and it could be controversial. Some people may say that it's the share of the poor that matters. Some people might say it's the total number. Okay. Anyway, so these are different things. So when you require a poverty measure, these are different things that you need to keep in mind. That how I'm like whoever is devising the policy for alleviating poverty is just like a pilot driving plane, right? And so you need to know how your plane is going to behave when you press different buttons. And these are the ideas. So different kind of transformations, how it should affect the overall poverty measure. If you find, for example, for the first example, if you suddenly find a poverty measure which actually is not giving you the desired result, then probably it's not the right measure that he was looking for. Okay? So we classify the properties into 4 categories. This is following our book on multidimensional poverty. So the first set of properties, they are called invariance properties. These properties ensure that poverty measures should not change under certain transformation of the achievement matrix. One example, just change the unit of measurement. Should your overall poverty change? If it changes, you have to be careful. Dominance properties. It ensures that poverty measures should increase or decrease due to a certain transformation in the achievement matrix. So, everybody else's income remains unchanged. If a poor person's income increases, overall poverty should fall. If the poverty increases, then there is something wrong. Third, subgroup properties relate overall poverty to either subgroup of people or group of dimensions. Here we will just focus on group of people. Group of dimensions will come in the multidimensional analysis. An example, suppose you have 2 groups in your society, group A and group B. Subgroup properties, it relates to the overall poverty. Let's take an example. Suppose you have a society and you have 2 different groups. Okay? You find, suppose there is an increase in poverty in group 1. Poverty in group 2 does not change. What would you expect overall poverty to do? Do you want overall poverty to go down? Maybe not. Right? So there are certain properties that ensure that these kind of inconsistencies are ignored. And finally, there are some technical properties that guarantees that the poverty measure behave nicely. For example, you get a poverty number. Suppose a minimum possible poverty number is minus 1.25, maximum possible poverty number is 79.52. What does that mean? It does not probably make a lot of sense. It may be better to just bound them between 0 and 1, some understandable number like percentages. So those technical properties ensure that poverty measures do not behave eccentrically, as I was saying. So let me start with the invariance properties. So the first property is called symmetry. The idea is that if a distribution is obtained from another distribution by just a permutation of incomes, I will just show you what permutation means, and poverty line remains unchanged, then poverty should not change. This is the idea. You have a poverty line, say z equal to 10. The original poverty measure, original distribution is 9, 4, 15 and 8. And suppose you get another distribution which is 9, 15, 4, 8. So you have just reordered, okay, change the order of the distribution. Should that change the overall poverty? Okay, so this is what the first property ensures, that the symmetry, that this kind of change, permutation of who gets what should not matter. The second one that is typically used is replication invariance. If a vector or if a distribution is obtained from another distribution by replication, the poverty line remains unchanged, then it should not change. So one is obtained from another distribution by replication if the incomes are repeated of 100. That means you create clones. Suppose you have a society with 10 people. You create another society by cloning these 10 people. So as if in the second society you have 2 persons with the same achievement. Okay, so you just clone. So you have just increased the size of the society by cloning people. Should that, of course, your number of poor may increase, but the share remains unchanged, right? You may consider one person as a group of person in the other society. Should poverty change in this case? This particular property, of course, who takes a more leftist approach and just interested in the number of poor people might say, yes, this particular society has larger number of poor. But then in that sense, would you just conclude that South Asia is more poor than Africa as a whole, only because South Asia has a larger number of poor population than that in Sub-Saharan Africa, although the proportion of poor is much lower in South Asia. So this is a debate. This property can be debated, but those who think that population size should also matter tend to say that if you replicate the population, if you create clones of people and create another society, overall poverty should not change. This is an example. So you have a poverty line of say 10. You have one distribution, the original distribution, which has 9, 4, 15 and 8. And then you get another distribution where you just replicate this. So you have created a clone of these 4 people here. And the idea is that the poverty should not change. Scale invariance. The idea is that incomes in one distribution and the poverty line, if they are changed in the same proportion, then poverty should not change. So suppose you have a distribution. Let me just show you the example. It's easier. So suppose you have this particular poverty line and you have the distribution, say 9, 4, 15 and 8. What you do, you double this particular, using this particular number, you double the poverty line, you double every income in this particular distribution. Should poverty change? Should the idea of poverty change? Because you are just increasing the poverty line, you are increasing everybody's income. It could be very much same as changing the unit of measurement, right? With pound and dollar, you have an exchange rate of say 1.6. So you are multiplying everybody's income in say UK by 1.6. It should not change the overall poverty. The related properties, this is called unit consistency, which is not as strong as this one, which just says that if you have a different unit of measurement, then the direction of poverty should not change. So if with a particular poverty measure, if you have a higher poverty in A than in B, if you just change in the unit of measurement, the direction should not change. A should still have higher poverty. And then the other one, which is the controversy between scale and this is translation invariance. Translation invariance says that if everybody's income increased in the same number, not increased in the same proportion, you add 100 pounds to everybody's income and also the poverty line, poverty should not change. So these two properties cannot hold together simultaneously. One is saying, so one is the leftist approach and other one is the rightist approach. This is called a rightist approach, where you increase or everybody's income by multiplying by a number. So the question is, a person has $1,000 and a person has $1 million. You multiply by 2, so one person has $2,000 and the other person has $2 million. Are these two similarly unequal? This is the question comes from there. Okay, scale invariance would say these two situations are equally unequal. It only matters how many times you are earning compared to another person. Whereas this is a more leftist approach, which says is the absolute distance that matters. We will revisit this property afterwards in the next week. Okay, but that is the main idea. So if you think that an additional income of the same amount, should keep the distance unchanged, okay, then you take this particular approach. And if you think that is the proportion that matters, you take the scale invariance approach. Focus. This is a particular property that distinguishes the concept of poverty measurement from welfare and inequality measurement. Because in welfare and inequality measurement, you consider the entire distribution. Focus, on the other hand, says that you focus your attention only on those that are identified as poor. So, if you have a change in non-poor person's income, it should not affect the overall poverty measure. When you have a change in a poor person's income, of course that affects, but when you have a change in non-poor person's income, it should not matter. And this is the focus axiom, which is especially applicable in poverty measurement. So if a distribution is obtained from another distribution by an increment to a non-poor person's income or achievement, and the poverty line remains unchanged, there should not be any change. This is an example. So you have this particular distribution, you get another distribution where you have an increase in the non-poor person's income. That should not affect the overall poverty. Okay, because we have set a threshold of say 10. Now if your help, your assistance is going to a non-poor person and you are saying I have done well, no, you are not. You have not helped those who you have identified as poor. So those were the main 4 invariance properties that are used in the single dimension or income poverty measurement. Let us now look at some of the dominance properties. The first one is monotonicity. It answers the question. I listed 3 questions. One question was, if you have an increase in a poor person's income, how should the poverty measure change? This is what it answers. So if you have a distribution obtained from another distribution by decrement in incomes among the poor, that means poor person's income goes down. Earlier I used if you have an increase in a poor person's income, the answer was poverty should go down. Here, if you have a decrement in incomes among poor persons and the poverty line remains unchanged, then poverty actually should go up, right? Over time, if you have taken a policy which has taken money away from the poor, should that reduce poverty? So if you have a policy which has taken money away from the poor, it's probably not. The overall poverty should go up, right? Very sleepy after lunch? So here is an example. So earlier you saw in focus, for example, you had an increase here from 15 to 16 and it did not change the overall poverty measure, right? Here on the other hand, you have a reduction in this particular person who is identified as poor because his income is less than the poverty line. So this person is poor and this person's income or total expenditure has gone down. So there is an increase in poverty. Yes?
Violates focus property, right?
Yes, focus.
Violates this property.
Which property?
Focus.
Focus is a property and
yeah.
monotonicity is another property.
Yes, I know.
Then the question?
Relative income poverty concept violates these two properties. Why?
Yeah.
Because we use median equivalent income poverty line as a poverty line. So when we increase the income of the non-poor, which means inequality increases. So this situation violates this property.
Yeah, so you need to revise that property in that sense, because your poverty line now is a function of everybody's income. So if you have an increase in the richest person's income, that increases your poverty line, and as a result, what happens? If everybody else's income remains unchanged, poverty decreases, increases. Wonderful. Yes, that can happen. Okay, so we are just following an absolute approach here. Very good. You are awake. Good to know. Okay, very well. Great. So like monotonicity, in these dominance properties, you will see mostly there is a strong version and then there is a weak version. The strong version says that poverty should change strictly in certain direction, and the weak version says that poverty just should not change in the other direction. So the idea is that in this particular example, here you are saying that if y is obtained from x, y should have strictly higher poverty, right? That's why this particular sign, strictly greater. Weak versions in general require that poverty should not go down. That's it. So it stops from moving in the other direction. So that's the main difference between the strict version and the weak version. So this weak version includes the possibility that the overall poverty does not change. For example, let's just take an example of the simplest measure that we generally use, $1.25 a day, head count ratio. Okay? How many poor people are there? 3. So the head count ratio would be 75%, right? How many poor persons are there? Here, 3. So what is the head count ratio? Is there any change in the poverty measure? So if you use head count ratio, it definitely violates the strict version. However, here it satisfies this version because at least poverty is not going down. It can remain unchanged. So a head count ratio satisfies the weak monotonicity. It does not violate the weak monotonicity, it satisfies it, but it does not satisfy or violate the stronger version. So if you really want, a policymaker really wants this change to reflect, then head count ratio is not the right measure. So even if you help the poor, but their number does not change much, a policymaker does not have any incentive to such kind of policy because head count ratio does not reflect. Okay, and we will show that head count ratio in fact does not provide any incentive to help those are poorest of the poor. We'll come back to that. Let me go through the properties first. The second property, dominance property, that has been used and is due to Sen, Professor Amartya Sen in 1976, is called the transfer principle. The main idea is that even when you are conducting poverty analysis, how the distribution among the poor matters. So, if you have a situation where you have, say, two group of poor people, one who are just marginally poor, just below the poverty line, and you have another group of people who are really heavily poor. You have one situation like this, and you have another situation where you do not have such an unequal distribution among the poor. Even when you have the same average income among these two different groups, the first group has a much larger inequality, and that, when you are measuring overall poverty, that should be discounted. This is the main idea. Okay, so the underneath idea is that when you are helping the poor, the poorest should also receive the assistance. The assistance should not just go to the headcount ratio, for example. If you just help or assist those who are just barely living below the poverty line, take them out of poverty, you have a large reduction in headcount ratio. But really, is that desirable? No. So transfer axiom ensures that when you are assisting the poorest, or the poor as a whole, the poorest get the benefit as well. That's the main idea behind the transfer principle. And is also, you can have strong transfer version, weak. So if you look at headcount ratio may satisfy the transfer principle, the weakly, not the stronger one. Okay, now the question is there a limit of transfer? The main idea is that if you take some amount, what is the main idea of transfer? If you take some amount from a richer person and give it to a poorer person, that means inequality has reduced, right? Is there any limit to such transfer? Suppose somebody has $100, somebody has $80. And if you want such transfer, which you may call progressive transfer, do you have such a limit in that transfer? What is the maximum amount you? 10. If you do more than that, of course it gets reversed. Very well. So you have given the answer. By the way, this following one, the last one, the red one, is actually important. What is the implication of the transfer axiom for non-transferable dimensions? You may have education or health, right? Income is taxable. You tax income, give it to others. I mean, although we are talking about income and consumption expenditure property, but I wanted to raise this issue because it will come back in the multidimensional context. Now suppose you are studying educational, poverty in education, and look at educational inequality among the poor. Is it possible to take education away from somebody and give it to somebody else?
Yeah, but you can transfer costs.
Yes, that is one way.
Transfer costs, maybe the cost of education that the poor kids are doing, you give them maybe grants.
Right.
And then you introduce new taxes for higher level. Yeah.
Yes, perfect. But when you look at the outcome, it is not possible to take somebody's 5 years of education and give it to somebody else. The main idea how the transfer principle may be used is, say you compare two different societies. In one society, you see some people have more than 12 years of education and rest none. You have another society where education is more uniformly distributed. In that sense, the first society may be more unequal. So you cannot transfer, but the transfer principle can be used to understand which is more equal, which is less. It looks like as if one distribution is obtained from the other, but no. It's hypothetically, it can be obtained from another distribution, but not exactly. But as long as you can reflect this inequality, that's the use of the transfer principle. Okay, so it won't always have to be that one distribution has in practice been obtained from another, but if hypothetically one can be obtained from the other, in that way you can use these two different distributions. Now we move to subgroup properties. Okay, so we see some kind of consistencies that are maintained when you deal with different subgroups. And it always comes, right? Subgroups, you are interested how the states or regions have performed, or all the regions has shared the reduction in poverty. All the ethnic groups has bear the fruit of overall poverty reduction. Okay, all religious groups and so on. So that's subgroup discussion or subgroup analysis is at the heart of overall poverty analysis. So suppose I use this term mutually exclusive and exhaustive. That means you divide them in group in such a way no two or a particular person cannot contain in two different groups. That's the idea, right? This is how we do subgroups. And at the same time you exhaust the entire group. So it is not that you are leaving somebody out. So when you are creating the subgroups, you exhaust the entire population, and at the same time no single person can exist in two different groups. This is how we make the subgroup. This is the assumption here. So if the total population size, as we have assumed, is n, and the distribution is divided into two population subgroups, we say x1 and x2, and with population size say n1 and n2. So this is how we create subgroups. This is for the definition. Now I just show it for two groups. It can be done for more than two groups, any groups you want. Okay. So the example, if you have this original distribution, you have one distribution with 9 and 4, another distribution with 15 and 8. Here n is equal to 4 and population sizes of each of the subgroups 2, and they add up to 4. So this is how we in general create subgroups. So the first is called subgroup consistency. James Foster was also involved with this particular property. So if a distribution is obtained from another distribution such that you have an increase in poverty in one subgroup, poverty remains unchanged in another subgroup, and the population sizes of each subgroup also remains unchanged, then poverty should increase. You see the consistency? There is actually an index that violates this particular property, which is an inequality measures, and when that idea is brought to poverty measurement, then that poverty measures also, those poverty measures also violate this property. And you will be surprised which inequality measure has this kind of property. Is the well-known Gini coefficient. The main idea is that for Gini, suppose you have two different, Gini coefficient is used for measuring inequality, and most of you know. And what happens, you have two groups, A and B. Inequality has gone down here, inequality remains unchanged here, population did not change, overall inequality can go up, which may be quite inconsistent when you are looking at this kind of consistencies. Okay? And a well-known measure that Professor Sen proposed based on Gini may actually be contagious to this particular problem. Okay? So that's why it's called consistency property, because it makes the comparison or practical analysis consistent. So this is an example. So suppose you have this poverty line and you have the distribution, and this is how we create these two groups. Now say y is obtained from x such that y1, which corresponds to this one, is 6, 4. So you can clearly see that this has gone down. Okay? So poverty in y1 is higher or lower? If we compare x1 and y1, is poverty higher in y1 or lower in y1? Higher. How did you get that? Which property can you use to conclude that? Monotonicity. Because monotonicity required that if you have a reduction in a poor person's income, others remains unchanged, you have increase in poverty. So by monotonicity, you can clearly see that poverty has gone up here. Now suppose y2 remains unchanged as x2. Then the idea is this greater than this, poverty in y1 is greater than x1, and that should be reflected in the overall poverty. Y should have higher poverty than x. That's the consistency argument requirement. The practicality of the subgroup properties, as I explained, is just to iterate that the evaluation of poverty reduction programs, if you look at reduction in different regions, of course you want it to be consistent. Otherwise, if you reduce in one region, other regions doesn't change, if poverty goes up, is quite counterintuitive. And it can be seen as an extension of the monotonicity property, but they are not exactly the same. Because monotonicity requires that poverty to fall when one person's poverty level is reduced, rest remaining unchanged. That's the idea. Subgroup consistency requires aggregate poverty to fall when one group's poverty level is reduced. But remember that a reduction in one group's poverty may be accompanied by both increase and fall, or increase or reduction in individual poverty. So that's where it differs from the monotonicity property. So monotonicity property requires that poverty to fall when one person's poverty level is reduced. And subgroup consistency says that poverty to move in the same direction when one group's poverty moves in some directions. So it's very similar to monotonicity property. The main difference is that in subgroup consistency, a reduction in one group's poverty may be accompanied by both increase and fall in individual incomes. Okay, so we are looking at the group as a whole, which may have been obtained by both increase and reduction. That's what was the crucial difference between monotonicity and subgroup consistency. Now, yes, please. Just a minute.
We are assuming fixed groups.
Yeah.
If you change the groups in between, for example, creating a slum.
Yeah.
For that population, the poverty will increase, but overall the poverty of the other group will decrease. So how to handle these situations in the set?
So you are asking that you have, suppose, one society where you have two different groups. You create now three groups.
No. Within the two groups, now you are moving people across the groups.
Yes, the movement.
Yeah.
That's another thing.
Yeah. If you move people across the groups, poverty of one group is going down.
Yes.
And the poverty of the other group is going up. How you assess total poverty?
This is the consistency argument in this particular situation. What it is saying particularly that if this kind of situation happens, then poverty measure should behave consistently. This is asking. Empirically, when you have change in different subgroups, and we will cover that particular thing in the next week's lecture, then you have to do different kind of decomposition analysis, which is just beyond this simple understanding. This is a consistency property. So if a poverty measure, as long as a poverty measure respects that, that's that. But what you are asking, intergroup movement, and that requires statistical analysis to take place. Okay? Because they are. Of course they do. Of course they do. Of course they do. And that requires further analysis. But this property is not invalidated for that reason. You see, if a poverty measure violates this property, poverty measure will behave really erratically, and that will not even take into account the changes that you are talking about. Okay? So this is just a consistency property that if a poverty measure respects, it behaves properly. But when you are talking about intergroup movement, that requires a separate kind of statistical analysis, which is different. And this particular property is known as additive decomposability. It says that if you have this overall poverty measure, which is written as like this, it is expressed as a population share weighted poverty levels of each subgroup. So if you have two subgroups, and you denote it by 1 and 2, then the poverty level of these 1 subgroup times the population share plus the poverty level of the second subgroup times its population share should give you the overall poverty. It's also a property that is used quite often in practice. Sometimes people who study theory might say that this is oversimplification, but those who are conducting empirical analysis may understand how useful it can be to understand, the decomposition of overall poverty across different subgroups. In that sense, it is very useful. And then one may also compute the contribution of a particular region's poverty to the overall poverty using this formulation, which is the population share of that particular subgroup times the poverty level of that subgroup divided the overall poverty. And that gives you the contribution of a particular region to the overall poverty. If, for example, you say that one region has 10%, one region has 10% of its population living in that particular region, but when you contribute poverty, you find 25%. It clearly shows that even though you have only 10% population living in there, its contribution to poverty is 25%. That means the region is doing quite badly in that sense. Sorry. I just wanted to focus on this one. So this property implies the earlier property, but the earlier property does not necessarily imply this one. Now, if you have this kind of breakdown, then definitely if you do not have any change in this particular group, but poverty in this group rises, clearly if the population share remains unchanged, you will have an increase in P. Right? So this particular property, if satisfied, it satisfies the subgroup consistency property, but not the other way around. If a poverty measure is satisfies subgroup consistency, it not necessarily is additively decomposable. And finally, the technical properties. The first one is called normalization. That means a poverty measure should be bounded between 0 and 1. This is just a regulation property, to make a poverty measure user friendly. As I said, it really is not going to be very helpful if you have a minimum value poverty measure ranges from 5.56 to 79.87. It may not make a lot of sense. Okay? So in general, the poverty measures are normalized to lie between 0 and 1. So 0 for no poverty and 1 the highest level of poverty. That is what is generally done with different poverty measures. And finally, the continuity. I am not going too far with this property, but the main idea is that this particular property prevents sudden jumps in poverty measure. Suppose head count ratio, for example. If you have, say, these 4 incomes that I was using earlier, suppose here 4, 9 and 8, 15. When you have a poverty line of 5, how many people are poor? When you have a poverty line of 5, how many people are poor here? Okay. When you have a poverty line of 6, how many people? When you have a poverty line of 7, how many people? Poverty line of 8? 1. Poverty line of 9? Suddenly 2. So your poverty line changing, but there is no change in poverty. Suddenly you have a huge jump, again no change, suddenly you have a huge jump. That is called not continuity. That lacks continuity. When you have an increase in poverty line, that particular person, when your poverty line increases from 5 to 6, this poor person's distance from the poverty line is increasing as well, right? So poverty should change. But if you look at just the head count ratio, for example, which just looks at the share of the population poor, it doesn't change. So there is discontinuity involved. So this continuity property, if a poverty measure satisfies this particular property, this continuity property will rule out head count ratio. Again, because if you have changes, it is not going to incorporate. Okay. Now I move to poverty measures, the poverty measures that are often used, and what are the policy implications of these different poverty measures, okay, and what kind of policy incentives these measures provides to policymakers. This is the most commonly used poverty measure, right? And everybody almost knows and used at some point of time the head count ratio. If Q is the number of poor in this particular distribution and total population size is n, then the head count ratio is simply Q over n, is the ratio of the population poor divided by the total population. That's a simple measure. The example, if Z is equal to 10 and the distribution is 9, 4, 15, 8, where 3 people are identified as poor, the head count ratio is simply 3 over 4 or 75%. What properties this measure satisfies? It satisfies symmetry, of course. If you change the order within the distribution, it should not change the number of the poor. Replication invariance, if you replicate, create clone of the people, okay, over time. The ratio of poor does not change. Scale invariance, if you change the scale or change the unit of measurement, no change. It is focused, okay. It does not change when you change the incomes of the non-poor. Normalization, it lies between 0 and 1. 1 means everybody is poor, 0 means no one is poor. And subgroup consistent, it's even decomposable, it's even additively decomposable. That means you can compute the overall headcount ratio as a population weighted average of the subgroup headcount ratios. That's possible. What doesn't it satisfy? It does not satisfy monotonicity. If you have a change in a poor person's income, okay, but everybody remains unchanged, headcount ratio does not change. It doesn't satisfy transfer. This other property, please ignore, I haven't talked about it. Okay, it doesn't satisfy continuity. Policy implication. It encourages a policymaker with limited budget to assist the marginally poor only instead of severely poor. This measure can provide incentive for policymakers to deliberately ignore those who are the poorest. Because if you help the poorest and their situation improves, but they do not come out of poverty, is there any change in the headcount ratio? No. On the other hand, if you channelize that resources to those who are just barely poor and they come out of poverty, you get a large reduction. Okay? So, it actually can deliberately give incentive to policymakers not to help the poorest of the poor. The next one is income gap ratio, which is thought to be, improving an improvement over the headcount ratio. What does it do? It reports the average normalized income shortfall of the poor from the particular poverty line. It also ranges from between 0 and 1. First, the average normalized income shortfall of each poor person is computed as z minus xi over z. So let's take the example over here. So if you have x is, let's go through point by point. So the average income gap is the average of all income gaps of this poor. So if suppose you have a poverty line of 10 and a poor person has an income of 5, the normalized poverty gap is 10 minus 5 divided by 10. How far you are from the poverty line. So you are looking at the gap, which headcount ratio doesn't do. So if a poor person's income increases from 5 to 6, the normalized gap falls from 0.5 to 0.4. Right? This can also be computed as by this, which is poverty line minus the average income among the poor divided by z, they are equivalent. So if you look at the computation here, you take the average of the incomes of the poor, which is 4, 8 and 9, and you get 7, and z is 10, then income gap ratio is 10 minus 7 over 10 is 0.3. Okay, now if income of the poor changes, this particular measure changes, unlike the headcount ratio, but it has certain problems. It satisfies these properties, replication invariance, scale invariance, and so on. However, it does not satisfy, just keep ignoring this particular property, it should be deleted because I didn't talk about it because of time. It doesn't satisfy transfer, continuity, and the policy implication is that it can be counterintuitive. If a poor person's income increases and the person becomes non-poor, poverty can increase. The main problem is, technically, it divides the gap only across the poor. Okay, so what is the idea? If you have, say, these 3 poor persons, right? 1, 2, 3, 8, 9 and 4, right? Now suppose one person becomes non-poor. Okay? Say this person becomes non-poor. Then let's see what happens. Right. Suppose this person becomes non-poor. Then you are left with 8 and 4, right? The average of 8 and 4? 6. So 10 minus 6 over 10?
10 minus 6
over 10, 0.4. So although this person becomes non-poor, you have an increase in the income gap. Because the only reason is that the denominator is changing here. They divide by the number of poor. When Sen proposed his first measure, he had the same problem of this sort. Anyway, this can be solved. This has been solved actually by reporting in terms of the censored distribution. Remember this? I introduced the censored distribution. The censored distribution, you do not forget the incomes of the non-poor. You replace them by the poverty line. And if they do that, actually, then instead of dividing by Q, it divides by N here. So as a result, when we are computing, the total number of the denominator does not change because N always remains unchanged. And as a result, that particular problem of counterintuitive problem can be solved. And this poverty gap can be expressed as income, the headcount ratio times income gap. You will see when Sabina or Anna, whoever is teaching tomorrow, will introduce the adjusted headcount ratio. Okay, MPI actually, MPI, many of you would have noted, is a product of two components, H and A. Okay, it's very similar. The idea is very similar. Okay, this is H times I, that becomes H times A. I'm just skipping the computation, got the idea. Then this particular, this particular method, poverty gap ratio, satisfies many desirable properties, but it doesn't satisfy transfer. That means it's not sensitive to inequality in the distribution of poor. That means if you look at the policy implications, it does not encourage a policymaker to distinguish between a marginally poor and severely poor while assisting. So definitely it will not encourage the policymaker to deliberately ignore the poorest of the poor, but at the same time it also does not provide additional incentive to help the poorest. It's indifferent. Whoever you give the help, there will be similar change in poverty. Okay? So with that particular aim in 1944, and of course Sen has introduced as well, but in 1944 is further away. 1984, not that far away. 1984, James Foster, along with Greer and Eric Thorbecke, created the FGT measure. And the FGT measure actually is, if you look at the measure, it's called square poverty gap. It's low on battery, I guess. This is the example. Oh, we skipped a slide. How come? Yeah. Anyway, it's coming now. Square poverty gap. So the idea is that it reports the average of square normalized shortfall. So we computed the normalized shortfall as the normalized distance from the poverty line, Z minus Xi over Z. What it does, it just takes simply a square of it. Okay, so Z minus Xi over Z, just square. So it weights a normalized gap by itself. So if you have a higher normalized gap, it receives a higher weight. If you have a lower normalized gap, it receives a lower weight. And by this way, you put more weight on the higher poverty gap. So that means if you improve their condition, it gets larger weight in poverty reduction. And this is how it is computed. Square poverty gap is 1 over n sum over gi star square using the normalized gap. Okay, so I'm skipping the computation part here. So it satisfies these particular axioms. I have not spoken about this axiom because this is going too far. We are going to be talking about it in this summer school. And this measure can nicely be presented using these different statistics, which is headcount ratio, income gap squares, and coefficient of variation. So you look at the overall poverty measure, you can break it into these three components and to see how the overall poverty has changed by changing in inequality, by changing is the average income of the poor, or by the changing the headcount ratio. And of course the policy implication that this measure can care for the severe poor first. The main problem with this measure though, it's not very intuitive. When you look at the headcount ratio, it's very easy to convey to the policymaker. It's the number of poor. When you look at gap, you can say if you give this much money to the poor, you can take them out of poverty. But when you look at the squared gap or FGT, of course it can capture if distributions are more unequal. But the main problem is that it's really difficult to give an intuition. You get a number, say 0.55 and a number 0.59, it's really difficult to find an interpretation of what this number is about. And this is the overall class that they proposed, which includes for alpha equal to 0 here, you get the headcount ratio. For alpha equal to 1, you have the poverty gap, and for alpha equal to 2, you have the FGT, which is squared poverty gap. Well, so far so good. The problem that comes in poverty measurement, let me just go through them and we'll come back again and again in the next classes, arbitrariness. The first question you ask, really, poverty line? Well, fine, you have a poverty line of 1.25 a day. Why do I believe? Poverty line probably is $1.3 a day. Poverty line should be $2.5 a day. Or why not? Maybe it's 50 cents. So poverty lines can always be controversial, right? So mainly two kinds of arbitrariness comes here. One involves identification, because if I change the poverty line slightly, how do I know how the number of poor will change? Or poverty measures. You can use different poverty measures, you get different numbers. And then you may argue, well, in one poverty measure I am looking at a reduction in poverty, in another poverty measure I am looking at an increase in poverty. Which one to choose? And that arbitrariness is always there. Whenever you have parameters, you have such arbitrariness, because parameters requires normative judgment, normative decisions. What to do in this kind of situations? And these kind of situations will come up even when we are doing multidimensional analysis. But there are way outs. We cannot say, no, this is wrong, but there are way outs to check. There are situations when we can say, suppose for every poverty line and for every poverty measures, poverty has gone down. If we can say that, that's a very strong statement, right? No matter what poverty line you choose, no matter what poverty measure you choose, poverty has gone down. But what are these conditions? When can we make such statement? And when we cannot? Let's quickly look at this. So suppose we have two examples. In one example, consider two distributions, this and this. Which distribution has more poverty by, say, headcount ratio? Here, if you have poverty line is equal to 7, you have 1. Here, 2. Fine. So this distribution has higher poverty. Why? Right? What if the poverty line is 10? How many poor are there? And how many poor are there? Now which distribution has more poverty? The second one. So you change the poverty line. With this particular measure, you have, right, different numbers. Similarly, which measure? You consider the same two distributions. Which distribution has more poverty by age if z equal to 10? Of course, we have seen this. Now, which distribution has more poverty by poverty gap? When z equal to 10? You see, this is reversed again. Here, x has higher poverty, here y has higher poverty. So your arbitrariness can come from both sources, by the choice of poverty measures, by the choice of poverty line. Now let's see if we have certain situation when we can say, no matter what poverty measure we choose, no matter what poverty line we choose, it has gone down or gone up. But of course, this is an incomplete ordering. When you construct an index, that's called a complete ordering. We are forcing completeness. No matter what, this is, I'm a dictator, I have devised, this is the poverty line, this is the poverty measure, and you can rank anything. And there is another situation, which you are more liberal, we say, these are the distributions, for sure we can say poverty has gone down or gone up. But there are certain situations we really cannot conclude. Okay, let us see what kind of situations we can see. So, to verify if one distribution dominates another distribution, do we need to calculate all measures for all possible poverty lines? I mean, that is the way out we saw, right? We check every individual poverty lines in order to see if it holds for everything and for all poverty measures. Is there a useful tool for such purpose to avoid this tedious work? Yes, there is a tool called stochastic dominance that is used in poverty analysis, thanks to James Foster and Tony Shorrock and also Tony Atkinson. This is closely linked to poverty ordering, where we can rank different distributions. That means compare. Just like comparing different distributions, here if we can say that no matter which poverty line you choose, no matter what poverty measure you choose, you can rank these two distributions. Let's see. It's intuitive. Let's see quickly. So two main types of poverty orderings or comparisons, as you call it: variable line poverty ordering or comparisons focus on identification step, and variable measure poverty ordering, which address the aggregation issue. The main procedure: choose a measure, identify the condition that two distributions must satisfy so as to be able to say that one has more poverty than the other. This is the variable line one. You choose a particular measure and then you use different poverty lines to say, if we can say, make any particular statement about these two distributions. And this is what we are going to use. Remember, we spoke about it at the beginning, right? So we are saying for a society with large population size, the typical CDF looks like this. And what does it tell us? It tells us the share of population having income less than a particular poverty line. Can you link it to something? Can you link it with a measure? Which measure? Yes? Head count ratio. Because head count ratio counts the number of poor, right, below a particular line. So, if the poverty line is 4, what is the H? Fx in this situation. This is H here. If the poverty line is 8, what is the head count ratio? This is the head count ratio. So, we just write it like this. So, this is the head count ratio of the distribution for poverty line 8, head count of the distribution for poverty line 4, right? So, we can use this concept to order head count ratios. It's actually even stronger, you will see. So, if the CDF of another distribution y lies nowhere to the right of the CDF of x, then y has no lower head count ratio than x for each and every poverty line. So, if you have a distribution like this, which distribution? So, if you take this particular poverty line, which distribution has higher poverty? Red, y. 8, which distribution has higher poverty? Y. So, if you have two distributions such that one lies to the right of the other, the right one always have it, does not matter what poverty line you choose. So, when you are doing the poverty analysis, why don't you just plot the two distributions at first? If you plot the two distributions at first and see one is lying to the right of the other, you don't even have to compute anything. You know poverty has gone down for sure. Okay? If they cross, I will come back, what can be done. But at least if you plot them and you see one is to the right of the other, and there are tests. There are different tests that can test a statistical significance, because in general you do not have the census. You have sample service. And sample service, they are subject to errors. So these curves, actually this is based on population, but these curves can have confidence intervals, whether they cross or not. So there are different kind of tests that you can do. So first thing, when you have these two distributions, check if they stochastically dominates one or the other. If you have, you know poverty has gone down, you don't have to worry about which measure to use, which poverty line to use. For sure poverty has gone down. This is called actually the first order stochastic dominance. So this is the main idea. If you look at these two examples, x and y, this is how you construct as I constructed, and for y, red one, you construct like this. There cannot exist any poverty line for which you are going to say that red has higher poverty than the blue. It is not possible. Okay? So this is how it looks like for distribution x and y. This is the mathematical statement of first order stochastic dominance. How strong is the FSD result? It says if FSD holds, then there is agreement for all continuous poverty measures satisfying symmetry, focus, scale and replication invariance. And so all the measures that has been proposed, most of the measures, if you have such situations, they all will agree for all poverty line. That is how strong the first order stochastic dominance results.
What about the transfer?
Sorry?
Will you satisfy transfer?
If they satisfy these, they will tend to satisfy transfer. So of course, yes. And if you want particularly transfer to satisfy, you have to look at higher order stochastic dominance, but lower order stochastic dominance implies higher order stochastic dominance. So for transfer you will see, as we mentioned, you need to look at third order, but first order implies third order. Okay, so if you have this, then most of the FGT class, okay, they all will agree that the poverty has gone down no matter which measure you use, no matter which poverty line you use. Great. Now what happens when CDFs cross? FSD does not hold. Can distributions be ranked in this situation based on for all poverty line? It can be, but not by first order stochastic dominance. Then you need to go to second order stochastic dominance, which looks at the area underneath the curve, and when you do that, it is related to the gap. So when you have this particular situation, they cross, you compare the area underneath the curve. I'm not going that far in this lecture. And if you compare the area and plot the curves of the area curves and they do not cross, then all measures, that satisfies again certain properties, including poverty gap, will agree. So head counts won't agree, but all these other measures will agree. So at least you know the conditions when you can make unambiguous comparisons or not. Similarly, for when you are talking about transfer, you need to do third order stochastic dominance, area under the SSD curve. So this is how, we are now moving to the theoretical domain, and I'm not going that far. But that is the main idea. If you are interested, of course, you are welcome to read the books that I suggested, the literature. And so, but this is the idea. So if you want to do, so if these such conditions hold, then it is possible to make unambiguous comparisons. And even if a third order ordering does not hold, dominance ordering does not hold, well, God bless you. You cannot compare. Okay? And finally, before I finish, this is the last slide, is the limited range poverty ordering. Because when you are looking at the first order dominance, you are considering the entire range of poverty line. One may say, well, whoever is earning $1 billion, who cares about their income, being poor or not? So you could say this is the range, so between 0.5 cents to 2.5 cents a day. Within this range, whether we have dominance or not. So even if crossing takes place outside this domain, it doesn't matter. As long as in between those range, there is no crossings, you can compare these two distributions unambiguously. It doesn't matter which poverty measure, which poverty line. Fine, I stop here. Okay? Questions and comments?
Thank you very much for combining all the properties in one presentation. Just a food for thought.
Yes.
Concept of stochastic dominance is heavily used in finance.
Yes, it has been brought from finance literature.
So what I was wondering that in the mean preserving spreads concept, if you can apply the same thing over here, you can get more mileage out of it. Not only looking at first order, second order, third order stochastic dominance, but they also talk about how you take things from the middle and make the tails more heavy. The riskiness of the distribution will increase, and this is what the stochastic dominance
What
is
is second
about.
order?
Yeah.
This is where you go to second order.
Yeah. So, but in poverty analysis, the problem is that how you'll get the information about the whole population. Whatever you are doing is a sample. So this is one thing that is bothering me, that although it is easy to say that we plot the whole distribution, but the distribution that we are looking is only a sample. It is not the actual distribution in the population.
It's a representative distribution.
Yeah.
So in general, let me speak so that everyone can hear. So the question is that here we are showing everything in terms of population. What happens when we just have a sample? Because we are missing out the population. The main issue here is that whenever you collect the sample, say national sample survey, they are representative of the population. So the way the samples are subject to error. But as long as you are collecting a representative sample, and I'm believing that the sample is representative, you can always compute the standard error, right? So in that sense, the same analysis will hold subject to what the additional thing you have to do. You have to look at the difference. Instead of looking at the distribution, you have to look at the difference of the distribution and compute the standard error. And as long as even the confidence intervals, they lie below 0, you have dominance. That should not be an issue. Yes, please.
My name is Sarah. I'm asking about something called severity of poverty.
Could you please be loud so that everybody can hear? Sorry about
Sorry, I'll try.
Yeah.
There is something called severity of poverty. Is it the same as gap squared?
Yes.
And I was also asking about the policy use of the gap squared.
Yes.
It can't be used for policy at all.
Yeah, let me explain.
Okay.
So the question is if the severity of poverty is related to squared gap and how it is used for policy. So yes, severity means you look at three different things. You have say the share, the depth, and the severity. Okay, so severity is related to inequality. So if you help, for example, in headcount, as I told you, if you help the marginally poor, a government, a policymaker will be benefited more in terms of reducing poverty. So it will help a policymaker with a limited budget to help those who are just below the poverty line rather than those who are the severely poor. Okay, that is where the term comes from. If you look at just the depth, measure just is sensitive to depth like poverty gap, it will not allow deliberately the policymaker to deliberately help those who are marginally poor and avoid the severely poor, but it will not distinguish. At the same time, it will not give additional incentive to help the poorest or the severest. Is the gap squared, which is sensitive to inequality, which says that your poverty measure will be reduced the most only when you help the severest. So the square gap in that sense will have the largest reduction if the assistant goes to the severest. So yes, this is the severest poor. So, and if that is what I was trying to say, this measure is very good, the FGT. The only problem is its intuitive interpretation. Okay, so if somebody could solve, if all of us were such a good mathematician and could solve when the largest reduction will take place, which is also not observable. So you see a change in this period to this period, it is really difficult to say what could have been the maximum possible reduction, hypothetical reduction, instead of what has actually taken place. But this is not exactly observed over time. Okay? So in those cases, it may become a bit difficult to interpret. But if we understand mathematics properly, the idea would be to first help. So if you have a limited assistance, first help the poorest, then the second poorest, then the third poorest, and so on. So that's the main policy, the supposedly, sort of policy relevance of the squared gap measure. Yes, please. First there and there. There first.
Thank you. I guess I missed the point.
Could you please be louder?
Okay.
So that everybody can hear. I can always repeat your question.
I guess I missed the point. Why we create a censored distribution?
You missed the point.
Yes.
Okay.
Thank you.
So the question is, why do we create the censored vector? So the main idea, as I began, the policymakers, they could be interested in three different aspects of one distribution. A distribution, as you saw, the cumulative distribution or the total vector. One is to measure the size of the distribution, which is welfare. One is the spread of the distribution, which is inequality, and the base of the distribution. Base of the distribution means you focus only on those, say, who are whose earning is less than $1.25 a day, for example, okay, or less than, say, $2.5 a day, or so on. So what you are doing, you are focusing on those who are below, but for poverty analysis, you are saying those on the above, they have met this threshold. Okay, so let's not consider their additional incomes. So here what we are saying, we are considering the income of those who are below, but here we are saying because they have met the threshold, suppose they have received, what it is preventing? It is preventing the situation whenever you have an increase in, say, a non-poor person. Suppose you are the policy maker and take a policy to help those who are non-poor, and you want benefit and you want credit for that. Should I give you the credit? You have not helped the poor, you help the non-poor. So you should not take any credit for poverty reduction. So if you censor that, we are saying if there is any increase in a non-poor person's income, we are still attaching the poverty line income as if nothing has changed. So that is the main motivation of censoring. Now you could say, why censor? Forget about those people. Just focus on the poor. Then the problem is that in the measurement, you may have this counterintuitive result where what happens here is that if you just focus on the poor and the number of poor goes down as poor comes out of poverty, you will have an increase in poverty numbers even when you have some non-poor person, poor person has become non-poor. Okay, just in the example here. Sorry, before. Still poverty gap. Yes. This is the example. Okay. So if you just forget those who are non-poor, in this example, suppose you look at here. You have their average as 7, so your income gap is 10 minus 7 over 10 is 0.3, right? Now suppose this person becomes non-poor. How many poor are left? 2. Their income 4 and 8. What is the average income? 6. 10 minus 6 over 10, 0.4. So that means you have an increase. So if you, instead of censoring, if you forget all those who are non-poor, you can have this kind of inconsistent result. So as a result, the trend has been in poverty measurement, to avoid such problems, the trend has been you retain the income of those who are below poverty line and replace the income of those non-poor by the poverty line itself. And that process is called censoring. And the other alternative is, I just explained, it's called truncation. You truncate everybody's income. Instead of doing that, you just censor. Retain them, but at the poverty line. That's the idea. We had a question here first.
Thank you very much for the presentation. I know that really, as you've rightly said, both the techniques and the model really develops on the tools being used by unidimensional assessments. I don't know whether the tool can also be used further to address aggregations and the composites.
Decompositions.
Composites, because this is a big problem that we have, that 30% of the population are poor. Most of the poor are in the rural areas, but not everybody in the rural area is poor. How do you really get to the poor? Mm-hmm. How do you really identify the poor within the population?
So are you talking about the identification problem or aggregation problem?
No, the identification.
Okay.
Yeah, you can over-aggregate and say that these are the percentages. Mm-hmm. But even where, as you say, there is urban poverty or there is rural poverty, mm-hmm. Who are the poor? How do you really select them and identify them within the population, mm-hmm. in order to target them directly? That's a big problem, yeah. in poverty reduction programs.
Yeah. So
and as a result, we always provide universal services. And universal services, over years, you realize that maybe the poor didn't benefit much from it
Yeah.
through an evaluation. Yeah.
So for that question, I will hold on,
Yeah.
and I will hold on for another week.
Okay.
And let's see if you find an
All right.
answer to this question. Okay, because this is what the summer school is for. So let's wait for that. We will come back, we promise. Yes. Oh, you have a question here first. Yeah.
Right. Thank you very much for the presentation. It's a broad subject, and you managed to just present it in 1 hour or so, and that was superb. Okay, my question is that we were discussing on the properties and of those the monotony and also the sensitiveness. I'm more, because we were discussing on one approach, that is the income approach, and I'm more interested on like, would these properties will be also appearing when we use like, let's say like the consumption approach instead of
Yeah.
the income aspects? Because for us now, the way we do it is, for me, from my country, is that we do the consumption patterns, and we divide them by quantiles. So we assume that the second quantile are those people who are most poor, and we just choose the bundles from there and set the poverty line depending on the consumption bundles. And I'm assuming if we're just talking about the income, do we still have the same problems appearing when we deal with the consumption patterns?
So let me understand properly first. Let me reiterate your question, and you tell me if I understood it properly. So your idea is that you first look at, you compute the, say, aggregate consumption expenditure for each household. You construct the quintiles. You assume that the bottom two quintiles are poor, and then you look at that particular expenditure, right? And then how do you construct the poverty line? Because that should itself be the poverty line.
Well, okay, so we have the 2,200 calories per day,
Right.
100 calories per day.
Right? Please go ahead.
So we have the 2,100 calories per day consumption expenditure.
Right.
Yeah, which is the daily intake.
Equivalent, 2,100 kilocalorie equivalent
Exactly.
expenditure. Okay.
So when you look at the people that are living in the second quantile,
Right.
you can choose the bundles of the goods that will give you the 2,100 equivalent.
Exactly.
So based on that, we just set the
Poverty line.
poverty line. Yeah.
So you determine. So it's just the process of determining poverty line is different.
Yeah.
Rest are same. Right? You have decided. What I'm saying, you have decided a poverty line.
Yeah.
So income poverty line, consumption poverty line, however it is. So your approach is, I don't know how I would classify it as a relative or absolute approach, but it looks like more like an absolute approach, because you just taking that particular commodity bundle, right? And then you are constructing the consumption expenditure and using it as poverty line, right? How does your poverty line change over time?
So, okay, we adjusted now next year when we have the price indicator.
Right?
So we adjusted by inflation.
So
But the same thing will be the 2,100 calorie will be. the
perfect. So that's an absolute approach, which perfectly fits the framework I just talked here. So all the properties will be satisfied, measures, analysis, distribution analysis, everything will just follow. You are just constructing the poverty lines with a different technique. That's it. Okay, it's same. Questions? There were questions?
Thank you. I was just wondering, following up on that absolute poverty question, is it a problem that with development and economic growth over time, this poverty will be basically eradicated? Or at some point there will be no poverty, multidimensionally speaking, at all anymore?
We haven't come to multidimensional yet. It's just single dimension. So let me understand your question. So your question is only about the absolute approach.
Yeah.
That absolute approach does not adjust for the change, overall
Exactly,
change in the
yeah.
society. Yes. So there are two extreme approaches, and I did not talk about it here. One is absolute approach, and many government has the incentive not to go beyond that, because by that way they can show much larger reduction in poverty. On the other hand, you have a relative approach, and if you take a completely relative approach, then it is problematic as well, because even though you have absolute reduction, you have got rid of absolute deprivations, you have no change in poverty. Okay? And in between, you could have something called hybrid approach, which takes sort of, a fraction of absolute, fraction of relative, and come between. Ravellian has worked, James Foster has worked on these. Okay, so they call a hybrid approach. Okay, so both approaches are extremes, and most of the developing countries, they tend to follow an absolute approach. And to give you an example, what kind of problems you may face, let give you an example from my country. In 2004-5, using a different commodity basket, which was determined, say, 1970s, they found the overall total fraction of poor, headcount poor, was 28%. In 2009, they realized, no, those commodity baskets was old. They revised the commodity baskets. For rural areas, there was a separate commodity basket. And in 2009, they said, actually, in 2004, the share of poor was 37%. Now, they have appointed another committee, which has come out with another set of commodity baskets, and now they are saying in 2004-5, the headcount ratio could have been between 45 and 50%. Yes, okay, so absolute approach can have its own problems, and as you are changing the commodity baskets, your poverty rates can change quite a lot. But this is the approach probably many governments tend to follow.
Yeah.
But it is possible that they look. There is another objective as well. Whether you want to get rid of those deprivations which you really think, with their obstacles to human welfare. For example, not having child mortality, child malnutrition, okay, not having sanitation, open defecations, not having electricity. They are probably the basic needs. Now, if you go beyond that, if you can at least solve those problems, yes, poverty can go to zero. But then you select a different set of indicators that are more accustomed to the situation that you are in. This is how we evolved probably. But yes, absolute approach, but that is the objective of the absolute approach, to get rid of the absolute deprivations which are absolutely necessary.
May I add one question?
Yeah.
How do you deal with population growth? You mentioned that replication criterion where for every, if you kind of clone every individual in the society, it should stay the same. But that's normally not the reproduction patterns.
No,
so
definitely.
Normally the poorer ones have higher reproduction rates. So that will tend to increase, I guess, poverty over time. Is that something that is
depends
desirable,
on how
or
you depends on how you see. Okay, this is a property that's the consistency property. If you have such situation, if you have identical people has replicated over time, then you do not have any change in poverty. But with population growth, suppose your population is growing, number of poor is growing as well. If the rate remains same, if you look at the share of poor, they probably remain same. You see the point? But it may be possible that what it's ignoring is that you have a population growth, but the number of poor did not grow that much, and you are saying the headcount ratio has gone down. What we have actually found in the analysis in India, that's the migration pattern that you were talking about. In India, what happened, the headcount ratio, it's been multidimensional poverty with Sabina. The headcount ratio has gone down clearly in rural areas and urban areas. But there has been a migration from rural to urban areas. Urban share has grown up by 4%. And when we look at the absolute number of poor, in urban area it has actually gone up. So although we are looking at using the poverty measure, the headcount ratio or even the adjusted headcount ratio has gone down, the number of poor actually in urban area due to migration and due to all these things has gone up. Yes, those kind of different kind of things has to be analyzed. But these are consistency properties, you see. Now if you clone, the question is then, if you clone from one society to the another, give me one reason why poverty should be different and which direction they should be different. Should poverty go up or should poverty go down?
if you clone all of the individuals?
If you clone the individuals.
Should probably be the same, but that's not what we observe.
No, of course, but what I'm saying is that if I ask you to suggest an alternative, that is also not there. I cannot say, I mean, if I take an absolutist approach, okay, it's a leftist approach, I just say number of poor has gone up. Everybody, by chance, they have the same right to live a standard life. So cloning, if it increases, it does not matter the population growth. There should be an increase in poverty. If you take that kind of approach, then you probably look at the absolute number of poor, forget about other poverty measures. Okay, so what kind of measures you will devise all depends on what kind of different properties, how you see the properties should be satisfied. So if you have such a property, I only care about the number of poor. As long as it grows up, poverty goes up. I don't care anything else. You look at the absolute number. Forget about ratios. Okay?
Thanks.
Yes, we have a question there. Last question. Wow, half an hour gone.
Yeah, okay, sorry for taking everyone's time. In global health,
Yeah.
you know, there is a long-standing debate between targeting high-risk populations and shifting population level patterns. So if you have a whole population where there's something structurally wrong with society, so everyone is obese, for example, then if you're looking for what differentiates the high-risk obese people from the low-risk obese people, you'll find some kind of genetic pattern and completely overlook the global pattern because you're differentiating between people within a society where there's a pervasive root cause of everything that's happening in the whole
Right.
society.
Uh-huh.
So in the same way, I could see a similar situation happening here, where if you're targeting poor people, you're finding within a society that is overall poor, you're not looking at how to move the whole society forward, but you're looking at how to change those individuals that may be different from other individuals within the same poor society, which may be related to individual risk behaviors, individual decision-making behaviors, rather than macroeconomic policy, foreign investment, things that shift the whole population. So do you also have that conversation
When we talk
going
about
on?
shift the whole population, how do you ensure that the fruit of the growth, suppose all the macro indicators, you look through growth,
Yeah.
suppose. How do you ensure that the growth has been shared by all equally? I mean, that is more
so
of
it
a
depends on the
micro-analysis.
intervention. If you have an intervention in place that can share it among everyone equally,
How? I mean, you have to enforce the procedure, or you are assuming it will automatically happen at some point in future?
so if it's, for example, global health,
Uh-huh.
you would be looking at, and you have an obesogenic environment, you would be changing the entire environment, yeah? So you'd be saying, okay, we need to have more parks so people can exercise, we need to have more exercise programs, we need to institute community-based social interventions so that everyone starts getting out more, school programs to exercise for people, you know, so you do a society-wide intervention rather than an intervention targeting only specific people.
So that should, as I understand, that should be context specific, no? I mean, if you are looking at malnutrition, would
Yeah.
you just focus on the entire society's food baskets, or would you provide such as food stamps and other things that we discussed this morning?
Exactly.
You provide things to those who are being
So
targeted
food
and
stamps
severely.
would be specific to high-risk people.
Right.
Whereas if you're doing society-level change, like, I don't know, sort of national level nutrition education or something like that, you know, you'll be trying to change the whole culture around food.
Right, so that's, I think, is context specific. I mean, it's, we cannot generalize that. So I think you
Yeah.
are talking about one context where this is possible.
But
Right.
maybe there's something similar in economics, where you could generate...
What do you mean economics?
Where you could change the macro level education,
Right.
macro level situation, so like employment opportunities
Right.
society-wide rather than for specific high-risk populations.
But that is where the micro studies differ from the macro studies. Macro
Yeah.
studies tend to assume a representative agent. That means one person represents the entire country population, and the assumption is that if I change for this representative agent, everything will change automatically, but that does not tend to happen, and
But
that's
then there
why,
are externalities.
sorry?
Then there are externalities.
I mean, look, this is the perception. I'm not going to debate that much here. Like, we can have a separate debate, honestly, but that is where I differ, and that is where I find macroeconomics sometimes a bit problematic, because instead of looking at the microanalysis and looking at particular situations, you tend to look, everything will be solved automatically. Anyway, that's a different in perception. I have no personal grudge against macroeconomics, but I find it a little difficult to digest. We can talk personally, one-to-one, because the time is up. I'm sorry. Okay.
In reality, too, when you're trying to make some of these interventions,
Right.
I mean, you don't have a vast amount of resources.
Yes,
so
of
you
course.
actually have to choose what will work both. And
And that's also
that's
different
what
context,
makes the
isn't it?
targeting very important.